Hello and welcome to EVM programming course. Today we have small but important topic, logs, events and transaction receipt. So you probably saw it and wrote it yourself, emitting logs, checking for the state of transaction, listening for specific on-chain events. This is the topic of our today's episode. So actually, let's just call this simple smart contract from our previous episode, and we'll call change owner in it because it emits an event. So after running this transaction, you can see here the information about it. So what it really is just the transaction receipt. This is the status of this transaction. Here we have status 1, which means that it was successful, assigned transaction hash, block hash, and all the other informations. And we also have very important section, which is logs. So seeing that example, what transaction receipt really is. So this is basically a record that contains important information about the outcome of the transaction process on Ethereum blockchain. When a transaction is executed, it is not only alters the state of the blockchain, but also generates a transaction receipt. The transaction receipt consists of these fields. Actually, only the first 6 are defined by yellow paper. The next ones are taken from Go Ethereum implementation. It uses it for convenience to easily get the state of the transaction receipt. However, consensus specifies that the transaction receipt has to have its type. So this is EIP 2718 transaction type, state root after executing this transaction, status of this transaction, whether it was successful or reverted, because you have to know that reverted transactions are also safe to the blockchain. Then all the gas that the transaction really used, because the gas that you pass in the transaction don't have to be consumed at all. So for example, you can put like 1 million gas limit and only use like 200k. Next is logs bloom, which I will discuss in a moment, and the array of logs that were emitted. So now, what are logs? Logs are the feature of EVM that provides a way to record data and events during the execution of smart contracts. Some key points about logs in Ethereum is its purpose is to record events and state changes that occur during the execution of smart contracts for off-chain agents to use. Next, logs are stored in the blockchain along with the transaction that generated them. However, they are not accessible from within the smart contracts. They are meant to be used by external entities such as user interfaces or server-side scripts. And you have to know that they are cost-effective because storing data in logs is much cheaper in terms of gas cost compared to storing data directly on Ethereum blockchain. This is because logs are not meant to be read from within the blockchain, but are intended for external consumption. And this actually makes sense because if you are reading something or writing something during transaction, each of the Ethereum nodes executing this transaction has to do the same operation. So if you have like 1,000 of nodes, the same read and write from the disk has to be performed, 1,000 times. Of course, it scales with the amount of nodes that you have, because everyone has to do the same calculations by themselves to verify if the state change is correct. And in case of logs, because you can only read them off-chain, you are only like asking one single node for that, and that's why they are cheaper. And finally, the log entry contains the address of the contract that created the log, a series of up to 4 topics, and a byte array. So indexes are used to quickly search for data. So you can think about them as indexes on databases or as indexes in your books. Because you are indexing something, you can quickly go through it and verify, and everything that is not indexed in log is put into the long byte array, and you need to know the ABI encoding of the specific log to read that, and you are not able to read it quickly from a given node if it is not being indexed. So now let's see how the logs look like. So you can see that we have like 5 operations. On logs, we have log 0 that has no topics, like no indexes. Log 1, which has a single topic, and the thing goes up to log 4, and you can see that the gas used is increased. This is just because the number of topics is increasing. So let's see an example. So we are storing two numbers into memory at memory address 0 and memory address 20, then we are pushing our topic and then offset and length of the memory to log, and then we are calling log1. When we are running that, these three instructions put 32 in hexadecimal onto memory. Here we are putting FF to the next memory part. Then we are pushing AA as our random picked topic value, and push length and offset of the memory that we want to log. And finally we call log1. Unfortunately, we are not seeing the transaction receipt and logs here, but this is more or less how it looks in low-level assembly. One thing to add here, you may be heard in Solidity that you may have either an event with 3 index values or 4 index values, or event with 4 index values, but it can't have its name. Because as you can see here in Solidity, if I try to do that, it will scream on me that there are more than 3 index arguments for the call. Which, well, like just looking at EVM, like should be possible because we have like 4 logs, but Solidity reserves 1 index value for the event name. This is how you can filter by specific events in case of Solidity. Of course, the error is not there if I remove it, and you can have like multiple more unindexed fields to whatever value that you want. Of course, if you are not exceeding the block gas. But again, you can have only up to 3 index in Solidity and generally 4. So how can we make sure that we can filter for specific events throughout like hundreds or thousands of blocks and be efficient? So EVM uses very clever trick, which is called logs bloom or bloom filter. So when you are emitting an event and emitting the log, the byte array, so what is done here is the log is being hashed, and then it uses the probabilistic function that maps the hash to the constant size array in a specific order. So for example, if some byte is set in this log, you are setting it to 1. And you are only doing that for the bytes that are set in this particular place. So let's say that we emitted like my event in some transaction, and let's say that we have like different transaction in the same block that emitted second event, and the bloom function assigned some specific bytes to here. It may also just take and override this value. It doesn't really matter here. So in this case, we are ending up with this structure, but you may think, how is that really useful? And the answer is simple. Then when someone comes and want to find the specific event, for example, let me find this specific event. So normally you would have to go through all of the logs of every transaction of every block and check if the transaction was really there. And by having this bloom filter, what you are doing, you are taking your query and mapping it the same way, and then for example your search return this, and this is compared against the bloom filter, and if the ones are set in the same place, that means that there is high chance that your log will be in this specific log and this specific transaction. Of course, you don't have like 100% confidence that it is there, but if something is not in specific block or transaction, then you know it right away, because if your bloom function results in this and you are comparing it against this value, this has nothing set here. So that means that this is definitely not in this bloom. So that's all concerning transaction receipts and logs. I hope you learned something new, and see you in the next one.